Welcome to our Delme podcast, Global Operations on the Go. I'm your host, Therese Snow. Today, I'm pleased to share that our topic is really new and different that perhaps many of our listeners are not yet familiar with. It's on green hydrogen. This is actually an area where many may be curious on how it works, and I have just the guests to explain it. Our guests today are Prashant Mysore, Damia Senior Offer Marketing and Strategic Business Development Director, and Stefan Kulemans, Infrastructure, Energy, and Materials Industry Business Value Consultant Expert. Gentlemen, welcome.
Thank you, Therese. Hello, Stefan. Hello, everyone. Thanks for having me here on this show to share some of my experiences working on hydrogen and hydrogen technologies.
Thank you, Therese, for having me here on the show. I'm excited to be here.
Oh, glad to have you. Absolutely excited as well, and certainly about today's topic. So, let's start with telling our listeners a little bit about yourselves. Prashant, why don't we start with you?
Sure, Therese. I'm Prashant Mysore, working in Dassault Systems Dalmia over 2 decades. And now I'm calling you from Australia, which is now at the forefront of adopting green hydrogen for power plants and green steel. Um, yeah, and my interest on sustainability dates back to my working experience with Japanese automotive companies, where I learned lean manufacturing practices, which is still the backbone of sustainable manufacturing. And of course, the global investments in green hydrogen and steel is also making my interest more on sustainability topics.
Well, certainly the right person to talk to, and it sounds like from Australia, the right location as well. So thank you, Prashant. Stefan, why don't you tell us about your background?
Yeah, sure. So as you indicated, I'm an industry business consultant and value expert for the I&M industry. I'm based here in Houston, Texas, which is also sometimes referred to as the energy capital of the world. So I've got a background in conventional forms of energy, and then more specifically in the oil and gas industry. I worked there for about 10 years in a variety of roles, including operations, project development, and engineering. And even before the word sustainability became mainstream, I was already active in that field, and I've always been interested in it. That's reflected in the fact that I've been like 6 years the lead for energy efficiency teams, first in Antwerp, where I started my career, and then here in Baytown, which is in the Houston area, and that was for ExxonMobil's largest refinery and petrochemical complex. Now, in the last 15 years or so, I've been active in the technology sector, providing digital solutions for the energy sector with a main focus on systems, projects, and operational virtual twins. And then transformed in the last 2 to 3 years, shifted my focus to more energy transition topics, such as the decarbonization, renewables, carbon capture, and the green hydrogen topic that we're going to discuss today.
Fantastic. It sounds like you also have quite an extensive background in energy, so that's great. So today we're going to dive into the topic of green hydrogen. From what I understand, green hydrogen is a clean burning fuel that's basically produced through a process called electrolysis. But can you expand more, of course, on what green hydrogen is and where electrolysis fits in? Stefan, can you explain?
Yeah, but first, I just want to take a quick step back because we have to realize that hydrogen production and consumption is not something new. There have been two major use cases for it in the past decades. The first one is in refineries to remove impurities like sulfur. And then the second use case is in chemicals to produce methanol and ammonia, which is a building block to make fertilizers and things like that. So these use cases cover about 90% of today's hydrogen production and amount to close to 80 million tons of hydrogen today. So I also want to point out that the production and consumption of hydrogen is very localized. So there's no international trade or infrastructure to speak of as of in the current day. Now, this hydrogen production is then mainly today as well for coming from gas, which is about 3/4 of the production, and the rest, about 25%, is in coal. Now, the problem that we have is that all of these production techniques produce an enormous amount of CO2. And so internationally, it's like a color coding that's being used to identify the different ways of how hydrogen can be produced. So gray, for example, is dubbed for the production processes that are based on gas and coal. And then green hydrogen, as you indicated, is a production of hydrogen where no greenhouse gases are created. So that is based on electrolysis. And without going then, without being too technical, it's a process where water gets split in two components, hydrogen on one side and oxygen on the other side. And that is done by applying an electrical field to water and an electrolyte environment that you need for conductivity. And we're getting into the technical details there. But bottom line, if you want to use 100% if you use 100% renewable electricity, like wind and solar, you can create hydrogen in a sustainable greenhouse gas-free way.
Absolutely. Thank you for that explanation, Stefan. It's really interesting and very detailed. So much to learn on this topic, obviously. So now on to you, Prashant. Why is hydrogen even in the picture? What does it have that other forms of energy don't have?
That's a good question, Therese. Hydrogen is one of the renewable form of energy sources which a lot of companies are actually exploring. The reason being abundance of availability of water, right? As Stefan beautifully explained, the process of electrolyzers, process of PM, which is proton exchange membrane, the whole process of hydrogen electrolyzer process is extremely kind of easy to productionize, and it is easy to consume in various industries, right? But what makes hydrogen one of the most efficient source of energy is that the clean energy, compared to traditional energy sources like gasoline, which is or diesel, green hydrogen has virtually no harmful emissions during combustion compared to the traditional sources, right? And additionally, it's the production process powered by renewables minimize the environmental cost, as Stefan explained in his question as well, right? It is also a clean energy carrier. The green hydrogen flexibility extends beyond transportation. It can be used in various sectors, including industries, even the clean energy industries, clean energy generation as well, and powering various processes. And as I said, like zero emission, unlike fossil fuels, green hydrogen produces minimal or no greenhouse gas emissions during its production or usage, which makes it a significant energy source for most industries. And it reduces environmental footprint or carbon footprint and contributes to combating climate change. So these are the some of the points which I can think of what makes hydrogen a prominent source of energy.
So, can you expand a little bit on what industries would benefit from green hydrogen?
I would say multiple industries, right? I would say I will start with steel. The steel industry stands to benefit greatly from green hydrogen through the development of green steel production. We see a couple of our customers are already on the green steel production, and the country where I'm talking to you from, Australia, especially South Australia, is investing heavily on green hydrogen powered green steel plant. One of the largest plants in the world is being set up in South Australia. And this transition towards green steel lowers carbon emission substantially, aligning to the global sustainability goals. So the steel is the first one. And generally metals, extending steel into metals, the broader metal sector can leverage green hydrogen to reduce emission, as I said, to align with global sustainability goals. And even the renewable energy itself, Therese, in the previous question you asked me, the green hydrogen is a game changer for renewable energy sector, offering stable energy storage solutions. So this is extremely important, especially energy storage could be a game changer. Transportation, we cannot forget this huge industry. Green hydrogen provides a sustainable fuel alternative. It is particularly beneficial for heavy duty vehicles, long distance travel, including shipping, rail, and even a lot of these buses are being tried and tested on the hydrogen as a fuel, where it significantly reduces greenhouse gas emission. And heavy industries in general, like cement, glass production. Stefan briefly touched on some of the industries which he worked on previously. Green hydrogen facilitates the decarbonization of processes traditionally reliant on fossil fuels, right? So the various industries, Therese, these are the industries which I can think of where green hydrogen plays a significant role in reducing greenhouse gas effect.
Well, it sounds like there certainly are many industries that can benefit. So thank you for that explanation. All right. So we talked about what green hydrogen is and why it is an important component of the energy transition towards neutral emissions. Stefan, on to you, please. Can you briefly summarize what the main industry challenges are when it comes to deploying green hydrogen?
Yeah, definitely. So the general consensus is that green hydrogen will represent about 15% of the global energy demand. And that means that we'll have to produce about 6 times more hydrogen than we do today. And referring back to the about 80 million tons that I said is being produced today, that means we'll have to produce about 500 million tons a year of hydrogen. Now, if you then look at the amount of electricity that is needed for this, that is an equivalent of about 80% of today's global electricity demand. So the setup or setting up the green hydrogen economy poses really enormous challenges, and there's kind of a couple that I can think of. So the first one is really not only that you need to invest and build up from scratch, because as I indicated, there's no real international trade or green hydrogen infrastructure. That today's footprint is really very localized. So you've got to set up all this infrastructure, which includes the production facilities, the storage, and the transportation. And then in parallel to that, you've got to vastly expand the renewable electrical generation, as I indicated. Now, that's from an infrastructure perspective. Now, because hydrogen is really produced and consumed very locally, besides the infrastructure, you also have to create the commercial networks of trade between the different regions and countries. So there's going to be countries, and like you're thinking Middle East, South America, Australia, as net producers of hydrogen, and then the regions like Europe and some countries in Southeast Asia like Japan, Korea as net consumers. So setting up these global networks is also going to be a challenge, because you really have to set up these commercial relationships between countries and private public entities. And then kind of the last thing that I can think of is really the finances and the costs. So not only is producing green hydrogen today a couple of times more expensive than with the traditional CO2 intensive methods, we're talking 3, 4, or even more times more expensive. But as you can kind of imagine, the size and the quantities needed are enormous. So the amount of financing that you need to gather is substantial, and the financial risk is also big, because this type of power and hydrogen assets that you have to build out is relatively new. It's never been done before in that combination. So you have an enormous investment risk, and you see for that more and more partnerships being coming to fruition, not only between the producers, but partnerships between producers and the consumers. So many of these projects can only go ahead until you have found a buyer and signed off a takeoff agreement, for example. So this extended ecosystem of players and stakeholders poses a challenge in itself, and how to keep then everyone on the same page with the interfaces that it involves, and then the exchange of information and collaboration overall. There are just kind of a couple of the main challenges that I foresee for the green hydrogen economy to take off.
Certainly, it definitely sounds like there are indeed challenges, as with any road to a positive outcome, right? So, Prashant, what would you say to this question? Are there any specific challenges, maybe that Stefan has not mentioned, that you would like to mention?
See, Stefan beautifully articulated some of the challenges, which I'm also seeing here locally. Obviously, we all know that green hydrogen is at the forefront of global transition towards sustainable energy. Some of these challenges, which I also foresee, are in terms of technology, right? Slightly deep diving on the technology part of it, optimizing electrolyzer design itself, proton exchange membrane, while PFM, which is PEM, which is proton exchange membrane technology, leads the pack. There is still knowledge gap exists regarding an optimal plant design, include factors like electrolyzer stack configuration, system integration, and then some of the balance of plant components, which we've been seeing, which we've been witnessing locally here. And there is also a huge workforce skills gap, right? As the green hydrogen industry is scaling up, a skilled workforce shortage is definitely visible. It's becoming apparent. Technicians and engineers with specific knowledge to operate and maintain these plants are definitely, that it's coming up. The training is being given. Obviously, sustainment programs are being actually made on the hydrogen part of it, right? And also the consumption of energy, the electrolysis process itself consumes currently significant amount of renewable energy as well. There is some optimization definitely needed, and we haven't done much analysis on storage and transportation losses. And hydrogen has a low volumetric energy density, which means that storing and transporting large quantities can definitely lead to transportation losses, especially the liquefied hydrogen. Stefan, you may know much better than me on this particular topic, and the technology cost itself. Proton exchange membrane electrolyzers and the fuel cells is currently the cost is slightly higher. I think obviously these are the initial stages. Fuel cells are not directly involved in green hydrogen production, but they are vital downstream application for converting hydrogen back into electricity. And we are also seeing, I was actually involved in a couple of customer workshops on pilot in Australia on this particular topic. So these are some of the technology and the business challenges which we've been foreseeing, Therese.
Absolutely. Thank you, Prashant. So this was really a great segue, I would say, into the next topic. I'd like to address this one and pose a question actually to both of you. So, what solutions are available if someone was interested in pursuing green hydrogen? Stefan?
Just want to kind of summarize and point out our way of addressing the challenges that I mentioned. And that is through kind of virtual twin experiences on the 3DEXPERIENCE platform. And when I say virtual twin, that really means kind of starting with the investment risk that I mentioned. We can help kind of project owners and developers using a virtual twin to model and quantify, for example, the levelized cost of hydrogen production. I indicated earlier that a lot of these projects, or most of these projects, only go ahead unless you find a buyer. And knowing what your cost structure is and being able to quantify the cost of production of your product that you're going to sell, in this case hydrogen, is really needed to minimize the risk of your investment. So what we do is we kind of take the business goals, the requirements, link all of them together, look at the physical world constraints, like weather patterns, variability of energy inputs, etc. And then we kind of model all of these constraints and link all of these together so that you have a complete picture of what your risks are, what the best configurations are, and so on. So being able to model all of that uncertainty and what I would call variability and optimizing the design based through the simulations helps our customers really choose the best configuration and really get a plant and a project that has the highest return on investments. Now, these type of capabilities are not only for the production and distribution assets, as I kind of described, and that's kind of the area that I have been focused on. But my colleagues within Dassault Systems for other industries, like industrial equipment, are focusing on the solutions or similar type of solutions that we apply within the manufacturing space. And referring back to what Prashant said, the building and the manufacturing of electrolyzers, for example. we also leverage data science like machine learning and AI on data from multiple sources and format that then to optimize, for example, schedules, look into costs, and to identify risks based on weak signals or basically getting early warnings to make sure that you kind of know or have a proactive view on where things can derail the execution of these type of complex large infrastructure projects. So we do that through our platform, 3D Experience platform. Now, a couple of words about the 3D Experience platform. So it's used to create work environments for these virtual twins that I've been describing, and a collaborative and integrated platform that is kind of that provides what we call the digital continuity, really kind of connects the dots between all of the different life cycles from engineering into project execution all the way into operations, and allows you then, of course, then to manage a portfolio of projects and assets in a consistent way. And that is really for several of our customers a game changer in the way of working. So the platform allows you to navigate and transition naturally from one work environment into another. And another component that's really important is the reuse and capturing of the knowledge as you go along. So capturing that in models, simulations, and asset information that you create along the way to be able to reuse that in operations. And so to provide operating and maintenance teams kind of the tools that they need to understand the impact of events or of their decisions, whether it's on cost or whether it's on quality and the amount of product that will be produced.
So, Prashant, what solutions are available if someone was interested in pursuing green hydrogen?
Yeah, Stefan beautifully articulated the technology or the business experience on 3D Experience platform, right? It's virtual twin experience, and I would just like to give simple steps for our prospective customers or collaborators on hydrogen working with us. What are those simple steps? The first and the foremost aspect of virtual twin experience for green hydrogen is modeling and simulation, as Stefan beautifully articulated. What does this modeling and simulation offer our prospects and customer is that they can actually create the production facility using model-based systems engineering, using extensive 3D modeling, validation of their construction processes, validation of design for maintenance, design for safety, and basically trying to showcase the virtual twin for all the stakeholders. It's kind of a stakeholder management, right? That's the modeling and simulation part of it, the first and the foremost thing. Second thing is collaboration, which is an extremely important topic where the owner operators of green hydrogen power plants to green steel, they have to constantly collaborate with EPC players, EPCs meaning engineering, procurement, and contractors. They have to collaborate with owner operators and all the stakeholders as well. So this collaboration is extremely important for on-time and on-target construction of new facilities as well. And the third important topic is optimization. This is where Delmia has its powerful solution on scenario planning, production planning and optimization, resource planning and optimization as well. This is where virtual twin experience can model various real world scenarios, fluctuating energy demand, potential changes into local infrastructure to see how the plant will perform under different condition, how well you can actually optimize resource utilization here. And not to forget about delivery and storage optimization, logistics optimization, inventory management, and all as a part of integrated logistics and supply chain, right? That's the third part, which I spoke about optimization. Fourth, and the important topic is about execution management. This is where construction execution management, our production execution, our manufacturing operations management will really come into picture. Delmia has a stronger portfolio based on Industry 4.0 or Industry 5.0 concept, execution management using both structured and unstructured data. This is where a lot of people, a lot of our technology partners are also talking about IT and OT configuration or contextualization here, information technology and operation technology contextualization. Stefan really articulated very well about how do we leverage AI and big data. And this is where contextualization of IT and OT data comes into picture, leveraging big data, and how do we actually utilize artificial intelligence to ensure we have a perfect execution management of either new facility or with the existing facility in terms of optimizing production processes. Last but not the least is innovation. Innovation, virtual twin experience really helps our customer innovation along the lifecycle journey. So innovation through model-based systems engineering, contextualization of various data, and AI and ML, and we also have augmented reality to really help our customers to deploy the solution on time and every time as well. So there are various technologies on the top of 3D Experience platform. We offer this to our customer in their innovation journey.
So, a very succinct way to explain our solutions and how this all fits in. So, thank you, Prashant. So, Prashant, one more question for you, sir. Would you say, is it fair to say, for example, that green hydrogen is our future?
That's a lovely question. It's kind of, I don't know whether it's my emotional answer or a logical answer, but I
Sure.
would anyway answer to that question anyway. Thanks, Therese. It's a global race to achieve net zero emission, right? We are all passionate about it. We at Dassault System at the forefront of helping most of our customer on a journey towards sustainable planet. I'm so passionate on that topic. In this journey, one of the contender is capturing the imagination of energy experts and policymakers is definitely green hydrogen. This is clean, renewable energy source. It promises zero emission during its usage and making it an attractive alternative to fossil fuel. But in my view, while green hydrogen presents a promising pathway towards a cleaner energy landscape, it is not a panacea, right? It offers exciting potential for decarbonization, yet realization as a mainstream energy source will depend on overcoming some of the existing challenges which Stefan beautifully articulated earlier, and also to foster collaboration between policymakers, industry leaders, leading technology providers like our company. There has to be a good synergy, right? And ultimately, a comprehensive approach that combines green hydrogen with the other renewable technologies will definitely help to serve the needs of infrastructure, needs of power, needs of an alternative energy source, right? And I would say by investing wisely and with the help of innovative technologies like virtual twin experience on 3D experience platform, we have to relentlessly help our customers and prospects to set the stage for sustainable energy future. And this is where green hydrogen plays a critical role.
Oh, absolutely, 100% agree. Thank you, Prashant. Stefan, just to repeat the question, what's your input to the question? Is it fair to say that green hydrogen is our future?
Well, Therese, I personally prefer to steer away from kind of making these type of claims. But what I know that is, for me, kind of is certain is that green hydrogen is definitely a great option. And in several cases, in fact, today is the lead or kind of almost the only option in the decarbonization journey that we're all on. Now, kind of projecting or predicting what the exact size or format will be of this exciting emerging green hydrogen economy and how it will look like, I think only time will tell. Now, it does emphasis because things are so unclear and basically the future will only tell. It emphasizes the need to choose a technology partner, in my view, that can go with you along this decarbonization journey and along this green hydrogen emerging economy, because you'll need capabilities and digital tools to be agile, to be prepared, and knowledgeable. And I think project and operational execution will need to be stellar to really kind of get the viable business going for yourself or for our customers. So yeah, that's in a nutshell my view on this.
So great information. Thank you so much, Stefan. Is there anything I haven't asked about green hydrogen that either one of you would like people to know?
Yeah, I'll take that question, Therese. Thank you. We've seen a couple of our customers in their journey towards green steel, right? The urgency to reduce emission to meet carbon neutral targets by 2050, especially in Europe, is pushing our steel producers swiftly to adopt new and more efficient sourcing and production processes that drives sustainability. This is where green hydrogen is playing an important role in the production of green steel. It also ensures favorable business outcomes. And this is what we have already seen with one of the pilot with green hydrogen plant, which we have seen. Hydrogen definitely has a considerably huge potential for steel makers to be on their decarbonization journey. This is definitely an exciting news for us. We already have a pilot which is going on, and then we also have seen a huge plant coming up in South Australia where these kind of technologies, the virtual twin experience on 3D experience platform can really help in expediting or making sure that these plants are operational on time and on budget.
Definitely sounds like there's a lot of exciting projects underway. So thanks for all that explanation. Really, there is so much information, so much vital, important information, and I'm sure our listeners have learned quite a bit. So it has been a pleasure speaking with both of you today on green hydrogen. Thanks again for being guests on the show.
Thank you, Therese. Thank you, Stefan,
Yes.
for initiating this interesting topic on green hydrogen and how Dassault Systems and Dalmia Solution can really help hydrogen players.
Yeah, and thank you, Therese, for organizing this and for having me. And I want to thank for everyone to tune in. Really enjoyed this. And if you have any questions, if you want to elaborate, feel free, of course, to contact me, Prashant or Therese.
Sounds great. And I also would like to thank our listeners for tuning in. To learn more, click in the links where this podcast is posted. I'm your host, Therese Snow, and you've been listening to Dummies Podcast, Global Operations on the Go.